Hello, everyone, and welcome to the Department of Energy's SBIR STTR FY25 Phase 1 Release 1 Topics webinar. My name is Zina Al-Yusuf. I am with the DOE SBIR Programs Office, and I will moderate today's webinar and provide you with some basic topic information as it relates to Release 1. Following this introduction, you will hear from the topic managers that oversee topics 1 through 11 as they clarify their expectation and answer some questions that you may have regarding their respective subtopics. During this webinar, you may submit your questions via the Q&A box located at the bottom of the screen. We will group and present these to the topic managers following each topic presentation. Please include the topic and subtopic number with your question. That will help us keep track of questions. Again, please include your topic and subtopic number with your question. If you have a funding opportunity or a non-topic related question, please save these questions for the Phase 1 Release 1 Funding Opportunity Announcement webinar scheduled for August 8 and August 9. Finally, a copy of the presentation and along with the recording of the webinar will be posted on our website under the Funding Opportunities webpage. This is the first of 3 webinars that will cover the Phase 1 Release 1 topics. There are 6 programs participating in this release, and we have about 95 subtopics. Today, we will cover the 2 programs we are for today, and they are Office of Advanced Scientific Computing, topic 1 through 2. Office of Basic Energy Sciences, topic 1 through 11. As you can see, the topic document was issued on July 8, and this week we are hosting the topics webinar. The funding opportunity is usually released about 3 to 4 weeks after our topics are issued. We do this to give you enough time to read through the topics document and ask questions so you can make up a more informed decision as to whether or not you might have something that is responsive to what we are looking for in this release. The most important date following the opening of the funding opportunity is the letter of intent due date, which is the first step you need to take in order to submit a full application. DOE is the only federal agency that requires a letter of intent. It tells us who you are, what topic, subtopic you are interested in applying for, and a little bit about why you think you are responsive to that topic. So basically, if you do not submit a letter of intent, then you cannot submit a full application to the funding opportunity announcement. In addition to the 2 programs we are covering today, we have Office of Biological and Environmental Research, topics 12 through 16, and Office of Fusion Sciences 17 through 22. The webinar is scheduled for tomorrow, July 24. If you are interested, please go to our website and register for that webinar and join us tomorrow for that one.
Excuse me, Zina.
Yes.
I'm sorry, but it seems like the participants are having trouble seeing the screen.
Okay, thank you. Let's see if I can pause the recording, reach out for the panel, the Zoom admin person to get some help, and then we'll resume. Thank you. As you can see, the funding opportunity is scheduled to be issued on August 5th. After that, we will have the funding opportunity webinars. This year, we are doing something different. We will have 2 webinars for the FOA. The first one is on Thursday, August 8th, dedicated to the overview of the application process. And the second webinar on Friday, August 9 is dedicated for the Q&A. So basically, you'll join the first one to listen for the overview of the application process, and then join us on Friday with a Q&A session to answer all your questions. This will be, both webinars are free, so you would want to register for the 2 webinars. We will let you know when the how to register. We'll email you registration links, and that way you can register. However, today we are going to discuss the topics in just a little more insight than what is provided in the topic document. Please remember to join our mailing list if you haven't done so already, so you can receive notification from us when topics are released, webinars, registration, and some good information applicable to each cycle as we go through the phase 1 process. We would like to bring to your attention that we use GovDelivery as a news application platform to send email and notification. Please work with your IT group to allow you to receive these emails. And now we will begin with the overview. I would like to remind you that Phase 0 Application Assistance Program is open to all first-time DOE applicants. So if you have never applied to DOE before and looking for application assistance, I encourage you to go online. You can find the link here, or go to our website under the applicant resources page and click on that link. That will take you to the Phase 0 website, where you can complete a 3-minute application to see whether or not you are qualified for that service. It is a first come, first serve service, but it is something that can help you go through the application process. Here we have an example of what's a topic look like. We always have a topic header. That is the blue banner you see below the topic title and above the description, and it gives you important information like if the topic accepts STTR, yes or no, and the maximum award amount for that topic. Not all topics have the same information. They vary by program and by topic as well. So please pay attention to such information. The general topic description explain what the topic is about and maybe some context on where it falls within the mission of the program. Below that, you see subtopic that describes specific opportunities in which proposals are requested. You will notice a good number of the topics have other subtopic. Under the other subtopic, you can submit proposals that fall within the general topic description, but do not fit with any other specific subtopics. After each subtopic, there is question-contact and then the name and email address of the point of contact that you can reach out to with your questions. Please note that every SBIR or STTR application must include the topic and subtopic to which you are applying for. That's just a brief overview, and now we will start with today's topics. Topic 1, David or William, please go ahead.
Okay, Bill, feel free to chime in as you wish, or do you want to start it? I can start it.
You're the lead.
All right, sure. So the first topic is for, first of all, the program is called Advanced Scientific Computing Research. We're the supercomputer division at the Office of Science at DOE. And we, in addition to funding the hardware and research in applied mathematics and computer science, we also fund the creation of software that puts into practice those ideas that we fund in terms of fundamental applied mathematics and computer science research. In this first, we have two topics. In this first topic, we're really aiming to take the investment that we've made, Advanced Scientific Computing Research, known as ASCR, that we've made in this software and try to get it out to a broader audience. So the two main subtopics concern deployment of ASCR-funded software and the integration into a commercial product of ASCR-funded libraries. All these subtopics must depend critically on ASCR-funded software. The difference between the first and the second is covered in the topic release, but loosely, if you're taking a standalone software package that has been funded by ASCR and adapting it for, say, a different computer language, a different interface, making it easier to use, adding a graphical user interface, that sort of thing, that goes in subtopic A. If you're taking a numerical library, for instance, or any other kind of library that was funded by ASCR and incorporating it into your own code, then that's integration of a library. And if you can think of something that isn't covered by subtopic A or B, but still depends critically on ASCR-funded software, then that would be the other subtopic. And I think the way this works is that Bill and I are here to answer questions that people may have.
Yeah, I'll just say that an obvious question is, is there a list of ASCR-funded software out there? There are links in the topics, so you can go there. But it's just the nature of funding research in this area that some software products can get developed that we may not even know about. And sometimes there are SBIR applicants out there who know an individual who's worked on OSCAR-funded software, and it didn't make it to the lists that you'll find if you follow the links in the topics document. But if it did make it into the topics document, that's software that has received a lot of funding, probably from multiple different projects, and is software that we feel really invested in.
We have two questions in the Q&A, and the first one is whether ECP-funded topics qualify. ECP was the Exascale Computing Project, and that was funded both by ASCR and by our sister organization in the National Nuclear Security Agency, ASC, Advanced Scientific Computing, or Advanced Simulations and Computing. I think you'd have to look at the pieces of software involved and determine which way they were funded. You could ask the developers. There's also a website on our website, science.osti, Office of Science and Technical Information, .gov. You can look up, actually, no, I think it's PAM's public. There's probably a link from the OSTI website, but in the public interface to the Program Administration and Management System, you can look up who was funded. That list will cover some of the things. So I'm sure that I haven't answered the question completely. Bill, do you have a better answer for whether ECP funded software was OSCAR funded?
Generally speaking, most of the ECP software is OSCAR funded or jointly funded with NNSA. There's only going to be a small subset of it that's only funded by NNSA. So if you're interested in ECP software, send us an email and we'll figure out the funding stream.
The second question, I'm not sure I understand. Do both of these have to be included? But I'm not sure what both refers to. So maybe the questioner can can clarify that question. The third question asks.
I'll just say, in case there are two major topic areas here. You only have to address one. It's deployment or integration.
Okay, if that's what the person was referring to, yes, that's right. The third question lists some very specific proposals and asks whether they qualify. Certainly, something that incorporates PET-C would qualify because that is OSCAR funded. MFEM similarly. In terms of the applications, what I would encourage you to do is to submit a letter of intent, and in that letter describe what you're trying to do, and then we'll be able to answer specific questions about whether the proposal responds to the call.
Yeah, philosophically, what we want to do here is get this OSCAR-funded software used in as many different technical areas as possible. So, it's highly likely that we will find your application area responsive.
And then the next question is very similar. It asks whether applications in photovoltaic design and photonics are responsive. And again, I'll echo what Bill just said. If it incorporates OSCAR-funded software, then it most likely will be responsive.
Thank you both. And I don't see any more questions. So the next topic.
I don't know if my colleague Carol Hawk was able to make it. Carol, are you on?
Carol, go ahead. Thank you.
I don't see Carol. Is she here?
Let me check if I can see her.
I don't think she is, so I can cover for her. The next topic is high-performance computing cybersecurity. And the main subtopic is strengthening isolation between HPC users. The big picture here is that high-performance computing is different from desktop computing, and it's different from enterprise computing and cloud computing in terms of its architecture, its interfaces, and in particular, the way it treats security. In particular, in HPC, the trade-off between security and performance is skewed very heavily toward performance. And so that leaves security holes. So what we're looking for here are solutions that we can apply not only, but in particular to the Department of Energy supercomputing centers that will strengthen the security, in particular on a node, if multiple users share a node, without affecting performance. When you read the topics, you'll see references to various white papers. I found the first of those published by NIST on the peculiarities of HPC cybersecurity really helpful. So if you're looking for more guidance as to what we need, I would point you to all of those references. As one example, direct memory access between nodes or between a GPU and memory on a node often bypasses kernel protections. So we need a different kind of solution for those sorts of things. So we have 2 questions. Let's see. No, we have 1 question on cybersecurity. Would the application of cloud native, i.e. Kubernetes, security features be responsive to HPC cybersecurity topic? If it specifically deals with HPC architectures, as the topic description points out, cloud computing is not the same thing as HPC. There are certain commonalities, so you'd have to make a convincing case that you're addressing HPC as opposed to, say, commercial cloud sorts of architectures.
Thank you, David. I just want to remind everyone to please include the topic and subtopic number with your question. This will help us keep track of questions submitted as we go through the slides and the topics. Thank you. I don't see any more questions, so we'll move to the next topic, 3. Elian or
Yiping. Yeah, I'll be, yeah.
Go ahead, please. Thank
Okay,
you.
all right, yeah, okay. So my name is Yiping Fan, and I'm with the Scientific User Facilities Division of the Office of Science, and I'll be helping cover the first 4 BES topics, 03 through 06, before I discuss the 4 topics I'll cover today. Here are some of the basic information about BES. BES supports fundamental research to understand, predict, and ultimately control matter and energy at the electronic, atomic, and molecular levels in order to provide the foundations for new energy technologies and then support DOE's mission, energy, environment, and national security. BES also plans and constructs and operates premier scientific user facilities, including X-rays and neutron sources in the nanoscale science research centers and SRCs. There are 5 X-ray sources, 2 neutron sources, and 5 NSRCs. And for more information, please, you can click the link in the topics file. There are also other links in the topic file for other relevant information as well, which can be helpful. Before I begin, I also wanted to add that for very specific technical questions, please send them in writing to the program managers listed under each topic and subtopic. In this manner, we can ensure that each question can be accurately and adequately addressed. So as I mentioned earlier, that BES builds and operates facilities, and many of the facilities are actually going through upgrades. Some of the upgrades are already completed, such as the APS just recently, and also the Linac coherent light source a few months ago. And the ongoing ones are advanced photon, advanced light source, ALS, and the proton power upgrade for the spallation neutron sources. And so a couple of the topics are actually related to addressing some of the challenges brought about by these upgrades. Okay, first one, the topic 3. This is aimed at taking advantage of the upgraded X-ray sources, as I alluded earlier, which will have higher brightness and they are more spatially coherent by using more advanced metrology instrumentation analysis methods to enable the production and the verification of variable line spacing, X-ray diffraction gratings for basically pushing towards diffraction limited performance, namely higher resolution and higher efficiency. Here we're looking for an innovative solution, a platform of sorts. Basically, in terms of methodologies and associated calibration, test samples, some instrumentation and software for improving the precision, accuracy, and dynamic range of 2D interferometric microscopy stitching measurements to enable metrology of VLS gratings with sub 10 nanometer RMS groove position accuracy, placing accuracy. The gratings may be fabricated on a flat or curved substrate with a local radius curvature above 200 meters and a length reaching up to half a meter. The new technology should leverage calibration and data processing techniques to allow improved performance of existing interferometric systems while requiring only minimal and relatively low-cost modification to the systems themselves. We are not interested in development of a new design for an interferometric microscope, nor are we interested in technology upgrades or modification applicable to one of the particular commercial systems. You can look at the listed publications for more information. Deliverables. Phase 1 really is about design of calibration test samples, development of calibration procedures, and the algorithms. Procedure for acquisition of stitching data and the stitching algorithm that, when integrated with the system hardware, up to satisfy the critical metrics, which is the 10 nanometer RMS placing accuracy. Testing of sample fabrication procedures, initial development of analysis software, testing with synthetic data. Phase 2 can be fabrication and measurement, prototype samples, development and analysis with prototype software, and reporting on system performance, including precision and accuracy of grading measurements. Any questions for this particular topic, number 3?
Let me see if there are any questions. Looks
Oh,
like,
there is
yes,
one. Okay.
there
What
is.
transverse resolution for transverse 10 nanometer transmission was described over the half meter field of view when resulting file could be need to be awarded 100 terabyte. I can't do this calculation, but yeah, I think it's a very good question. I'll take that back, and then we'll basically discuss with the proposing facility. Yeah. Good question. I can't really answer this right now off the top of my head.
Thank you so much. I don't see any more questions for topic 3.
Okay. All right. So next up is the topic number 4.
Yes, and it's also
Yeah, myself. Yeah, I'll be covering for four
Yeah.
topics until Matt takes over. Yeah.
Go ahead.
Matt and Dava and Eliani, feel free to chime in if you, yeah. Okay, so this topic is looking for innovative concepts that can work in conjunction with strongly taped undulators to enable high gradient power conversion, achieve greater than 5% extraction efficiency at less than 200 nanometer wavelengths. And 2 approaches are considered here: developing an igniter scheme for high repetition rate FEL oscillator, or tailoring the buildup on the signal over a few passes as possible, starting from the spontaneous emission. There is a focus on the experimental development of these innovative schemes in an accelerator facility setting. This is also partially motivated by the idea that the strongly tapered undulator offer more viable practical solution to the emergent compact industrial FEL applications. For example, the EUV lithography for the chip industry. There are two subtopics. Subtopic A, we're looking for cost-effective, compact igniter scheme for high-efficiency FEL systems, which entails the development of innovative approaches for high-efficiency FELs where the high gradient power extraction is initiated from a low repetition rate intense signal that can be achieved using harmonic multiplication or alternative microbunching scheme. The optimization of the system must include analysis to ensure the FEL cavity dynamics to achieve the target greater than 5% efficiency. Just for reference, typically, let's say the LCLS FEL, the extraction efficiency is of the order of 0.1%. So it's like we're looking for something much greater, a factor of 50, at least a factor of 10. At shorter wavelengths, this scheme should include the means to couple in the pulse or the microbunching beam into the taper, undulate, or trap the emission radiation in the FEL oscillator cavity. Subtopic B is for basically coming up with the idea to enhance the buildup in the oscillator with tapered undulator system, which is the development, essentially is about the development of a mechanism for assisting the buildup from low signal to very high circulating power in a tapered undulator-based FEL oscillator. Schemes can be developed to maximize the gain at the frequency of interest during pass-to-pass amplification to speed up the buildup as much as possible. The goal is to achieve high efficiency power extraction in a relatively small number of passes compared to the total number of pulses in the drivetrain. Proposals for seeding method without a pass to high efficiency and compactness will be considered non-responsive. The main innovation here are related to beam and radiation manipulation schemes compatible with high efficiency FEL at shorter wavelengths. We're not interested in laser development for seeding since they will be wavelength specific and then not easily scalable. In terms of the deliverables, in phase one, a pre-bunching or an efficient subharmonic seeding method should be demonstrated and optimized numerically in combination with the downstream high-efficiency FEL system. In phase two, experimental proof of concept of the proposed scheme should be demonstrated at an accelerator laboratory and then qualified with a greater than 5% efficiency. A complete system should be demonstrated in both phases, emphasizing optimized FEL oscillator efficiency. Okay, so this is for topic number 4. Any questions?
Let me see if there are any questions. I don't see any questions submitted.
Okay.
So we will move to topic
Number
5.
5, okay. Okay, so for topic number 5, excuse me, let me drink some water. We are looking for to basically develop an advanced slope sensor for metrology of the X-ray mirrors with sub 25 nanoradian RMS precision over at least 15 milliradian angular range. And this system should be compact and easily integrable into new or existing X-ray metrology system at synchrotron and other X-ray facilities and require minimal maintenance. This is essentially a new type of autocollimator made, I guess, here in the US, not by international vendors, which have many performance limitations, especially for application extended beyond mirrors to include gratings, glazed or lamellar ones. The performance specifications are listed. Just a few of them I'll mention here. Again, this is 25 nanoradian RMS and then 15 milliradian angular range. Stability, few hours. Size is as small as possible with a mass less than 10 kilogram because it's going to be mounted on some sort of stage. And acquisition rate of 100 hertz or higher. So these are very specific requirements. Deliverables again, for phase one, basically will be a conceptual design and initial testing of the design concept. In phase two, we're looking for the company to fabricate and validate a fully functional prototype slope angle sensor for metrology for high resolution X-ray reflection gratings in the mirrors. Okay, so this is for topic number 5. Questions?
No questions submitted, so we can move to the next topic.
Okay. All right, so this is my last topic I'll cover, number 6. Here we're looking for the development of a closed cycle sub-Kelvin measurement capability optimized for X-ray scattering beam lines to enable the studies of quantum materials and quantum devices, specifically compact X-ray synchrotron beamline compatible dry helium-3 refrigerator. So we are looking for innovation in the design and implementation of a closed helium-3 cryo system, which can overcome the X-ray beam heating to allow for scattering experiments to be performed on samples held at sub-Kelvin temperatures on X-ray synchrotron beamlines. Such a capability will enable the study of fundamental physics of quantum states of matter, as well as in operando quantum devices. So usually these devices only work at very low temperatures. This will require the advancement of a closed cycle refrigerator design to create a new class of system which can achieve basically a more than a milliwatt cooling power at a base temperature of 300 millikelvin in a portable form factor. The design will need to be robust, amenable to X-ray scattering geometries, and mitigate X-ray absorption, heating in the vacuum, and the heating shield. We are not interested in a system maximized for ultra-low temperature, meaning that less than 250 millikelvin, without the necessary cooling power, nor a system unable to achieve the sub-1 Kelvin temperatures. The system should not be a redesign an existing system with X-ray windows, which does not address the need to increase the cooling power at the sample position to handle beam heating, because when the sample is illuminated by, basically hit by the X-ray beam, it will actually create heating. So for deliverables, phase 1 will be for design and modeling and then simulation to develop and theoretically verify a system capable of meeting these critical specifications. Potential fabrication of partial components for testing with the existing systems or a beamline test of beam system interactions. So that's phase 1. Phase 2 will be for the fabrication a complete prototypical system prototype, offline lab tests of performance with and without a heat load, optimizing of the closed cycle refrigerator tail, vacuum and heat shield for X-ray scattering beamline geometry, with incoming and scatter beam considered in the beam heating in tail and shielding. So this is for 6. Any questions?
I don't see any question submitted, so we can move to the next
Okay.
topic.
Okay, I think Matt.
Thank you so much for covering all these topics.
Oh, no, not a problem. Yeah.
We appreciate it. Okay, topic 7.
Hello, my name is Matthew Frost, and I'm a detailee supporting neutron technology development within the Basic Energy Sciences Scientific User Facilities Division. In particular, this topic is focused on advanced neutron beam optics technologies. We have two subtopics. One is neutron polarizers and analyzers using magnetic thin films, and the second is neutron monochromators and energy analyzers. These developments are sought to improve the performance and manufacturing techniques of these technologies to manipulate thermal and cold neutron beams for scattering instrumentation at our nation's neutron facilities. So I'll go to the first component, neutron polarizers. So we're interested in development of a reliable domestic supplier of thin film neutron polarizing optics. These are optics that filter a certain spin state, resulting in a mostly polarized neutron beam suitable for a wide range of materials studies. These are custom components and can usually be purchased independently from the rest of the optics at an instrument. We are not looking for a vendor to necessarily produce an entire incident beam system, just the singular polarizing component, as this is a common upgrade at scattering instruments. Performance should meet or exceed those stated in the key requirements of the cull subtopic, and utilize a neutron reflectivity measurement to show achievement of those requirements where applicable. The successful phase one result would be the reliable production of test surfaces that meet or exceed the key requirements described in the cull subtopic. And this would be shown in neutron reflectivity curves, as well as microstructure layer features that directly impact polarization performance. A successful phase two result would be fabrication of a market-ready polarizer for a defined instrument application. For neutron monochromators, we're interested in the development of reliable domestic suppliers for monochromator crystals. These are single crystals that can be used to deviate neutron beams of preferred energy towards different scattering instruments at our user facilities, which enables the installation of multiple instruments on one primary beamport. These can also be used as energy analyzers in neutron spectrometer backend systems. Both of these require a defined crystal mosaic to meet instrument resolution requirements, and this is where the key innovation lies. Being able to define, quantify, and deliver consistent monochromator crystal performance across a range of sizes and crystal materials is critical to success for proposals that target this subtopic. Performance should meet or exceed those stated in the key requirements of the cull subtopic, and utilize a measurement of crystal mosaic to show achievement of those requirements where applicable. A successful phase one result would be the capability to either produce or procure monochromator grade single crystals and confirm performance that meets the specifications defined in the key requirements of the subtopic. A successful phase two result would be the application of those crystals in the development, design, and fabrication of a crystal monochromator system for a defined instrument application. Expected partners in this kind of endeavor would be existing neutron source operators. They are really your best path with regards to developing a capable technology. Those facilities are also your most likely customer and your best resource to understand the market need. And the market is not just necessarily world-class neutron sources, but it could also be university scale research reactors and other systems of that level. If you have any questions, contact Mikhail Zernikov, and we can figure out how to answer your question if needed. Thank you.
Thank you. There is one question. Are you able to answer questions or just direct it to Dr. Zernikov?
I can answer questions. So specifically, these beam optics would apply at either the SNS at Oak Ridge National Laboratory or the high flux isotope reactor at Oak Ridge. But of course, these technologies could apply anywhere where there happens to be neutron scattering. And so, but the obvious application is our scientific user facilities.
Thank you so much. I don't see any more questions, so we'll move to the next topic. Topic 8. Shannon?
Yes, thank you. My name is Shannon Siston. I'm a detailee working with Claudia Cantoni to support the SBIR STTR program related to the nanoscale science research centers that are among the DOE BES user facilities. So we put forward topics that can support development of technologies that address the needs of our centers and center users. So we have one topic with one subtopic for this release, and that's number 8, nanomaterial integrated microelectronics for IR detection and imaging. So for this, we're looking for development of a commercially viable system to provide high sensitivity and energy efficient detection of shortwave infrared wavelengths. So we call it SBIR. That's the range of 1 to 2 microns. And this is useful for various detecting various chemical and environmental data that aren't accessible with visible light. So SBIR is kind of critical in many industries such as semiconductor manufacturing and agriculture, and has potential for imaging in our nanoscale science research centers. So right now, the most common SBIR detectors and cameras utilize indium gallium arsenide for the photodiode layer, which has some inherent shortcomings, including dark noise count that requires cryogenic cooling, large pixel sizes, and complicated fabrication, which ultimately is expensive. So we have subtopic A to develop commercially viable system for IR detection and imaging using nanomaterial integrated microelectronics. So in particular, we're looking for proposals that develop a system that capitalizes on unique properties of some novel nanomaterials for high sensitivity and energy efficient SBIR detection. Recently discovered upconverting nanoparticles and avalanching nanoparticles can convert SBIR wavelength in the 1 micron to 1.8 micron range into wavelengths that are detectable by silicon. So basically, these materials bring in higher wavelength, lower energy light, and then emit shorter wavelength, higher energy light. So these avalanching nanoparticle and upconverting nanoparticle enabled SBIR cameras could have a layer of nanoparticles integrated with the silicon sensor. And we're hoping that these could have lower noise, less need for the cooling, higher pixel density, and be lower cost. So as far as deliverables go, for phase 1, we're looking for demonstration of a system that uses these novel nanoparticles to detect incident SBIR photons in a system that leads to detection by a silicon system. So detection of IR photons in the range of 1150 to 2000 nanometers or so, and then use a silicon detector to detect emission at wavelength less than 850 nanometers. And the key performance parameters we're looking for are signal to noise, read noise, dark current levels that would be comparable to the indium gallium arsenide systems. And then for phase 2, deliverables, we're looking for a prototype of a sensor that uses these novel nanoparticles integrated with a silicon CCD that can acquire digital image from incident IR and then have the detection by the silicon. So this could include like a smooth film of these novel nanoparticles integrated with a 2D silicon CCD. And we're looking for prototypes that demonstrate sensitivity, uniformity, and energy efficiency at a level better than the comparable indium gallium arsenide detectors. So we do just have the one subtopic, but of course there's B if you have some other ideas beyond that that are still responsive to the topic. And Claudia Cantoni will be the main point of contact for questions, but I can try to answer if you have some here today.
Okay, there looks like there is a question in the context of semiconductor manufacturing and agriculture. How does agriculture industry benefit from this innovation? In more details, please.
Right, so I see that question. This is going to be a little bit outside of my technical depth. So I think in general, it's going to be for use in various sensors. So I understand that within the SBIR. Go ahead.
I'm good.
Dr. Kim, please mute. Thank you. Thank you. Go ahead, please.
Sorry. In that SBIR range, I understand there's some chemical and environmental data that's of use, but I really don't know details beyond that. Perhaps Claudia might know. Ana Maria Perez.
Okay.
I'll get back to you.
Can we use nanostructured devices like moth eye architecture?
Hmm. I don't know a lot about that architecture. If this approach is detecting SBIR, but is not using these avalanching nanoparticles and upconverting nanoparticles, then I think it could fall into the B category. And perhaps a conversation with Claudia might help narrow down whether that would be responsive to this call.
Thank you. And it's better for the person who asked the question to send an email directly to Dr. Cantoni. The email address is on the screen and also included in the topic document.
Thank you, Zina.
Thank you. The next question is, please comment on what DOE sees as some of the ultimate application for this technology. This is regarding, topic A, but 8, I'm sorry, but does not refer to which subtopic.
And we only have the one subtopic for this, so maybe I can take a crack at it. So these SBIR detection has a lot of application right now in the semiconductor industry. So I guess so far folks have been using these kind of detection to inspect and monitor the quality and reliability of various integrated circuits. But there's also potential to be able to use technologies like this in our nanoscale science research centers to look at a lot of different materials that have kind of optical transitions or band gaps at energies below the range of silicon detectors, such as quantum emitters, 2D materials, photovoltaic materials, perovskites, and so on. It could be used in cathodoluminescence.
Thank you so much. Okay, we have a question, but there is no topic number. Might a solar PV cell tuned to relevant band be useful to developers if it's faster than
Then gallium arsenide.
gallium arsenide? I
I
don't know which topic. I read the question, but there is no topic and subtopic number. So we can go ahead, Shannon.
Yeah, and if this is for 8A, I think if I'm understanding it well, this might be outside of the responsive scope, but perhaps a follow-up with Claudia might be helpful.
Okay. Okay, we'll move to the next topic. Thank you. Dr. Kim, are you online?
Yes, I'm sorry to be late. So then my topic actually is for the alloy, super alloy development or super alloy. You can coat whatever. So then at high temperature, under high steam concentration, alloy cannot survive very long time, and alloy can be insulated. So then, as you know that the RSOFC can have two functions. RSOFC can produce electricity in fusion mode, and also then RSOFC can produce hydrogen in electrolysis mode. So then instead, and the metal interconnect is very important for the cost of reduction. So, but however, at high temperature, under high steam concentration, and mirror interconnect cannot survive very long time. It can be brittle. It can form some kind of insulation, and also then some components can vaporize into the electrode, then can form some kind of different phases. So if you see the program work scope, then I explained very well on phase one effort. So then you have every applicant should identify the corrosion mechanism and also experimentally evaluate and characterize metallic corrosions, pattern cell or bench scale, whatever you like. But you should run under very high steam concentration, above 90%. And you have to run at least 500 hours. So you have to figure out, okay? And you have to also then figure out two things: corrosion mechanism and how to prevent. Okay. Any questions?
Yes, there's one question. Do we need a DOE lab as a partner or a commercial firm to partner with in phase 2 for this topic?
Yes, definitely. I like you have good partner with the national lab and industries. Okay.
Okay, thank you so much, Dr. Kim. One more. Oh, there are 3 more questions. What does Dr. Kim see as the primary R&D bottleneck regarding alloy corrosion with the RSOFC?
Okay, so then for hydrogen production, okay, so we are using very high steam concentration. So then high steam concentration can make the superalloy miserable for our application. Okay, so I think you know better than I, and based on my previous experience, then it cannot survive very long time. Okay, mechanically and electrical conductivity aspect.
Is this primarily focused on the alloy development or a particular part?
Oh, this is only focused on alloys, okay? Interconnect, metallic interconnects.
Are functionally graded material using existing alloys in the family, or are you looking for new alloys?
Okay, so it's up to you. So you can use existing alloys, then you have to improve. Or if we have really good ideas, then you can develop new super alloys. Why not?
Oh, here's another question. If we can use existing alloys, are any alloys ground ruled out?
No, so then so okay. Final goal for this project is to improve metal interconnect lifetime, okay, without losing any kind of very little degradation, okay? So that's the final goal.
Thank you. No more questions. Thank you, Dr. Kim.
Thank you.
Topic 10, William, are you online?
Yep, I'm right here. Thank you, Zena.
Thank you.
All right, so yeah, the next 3 subtopics here are generally focused on subsurface technologies. And I'm William Vandermeer with the Geothermal Technologies Office, and I'll lead off with the geothermal topic. So for this go-round, what we wanted to focus on was mineral scaling. And what that refers to is that there are various minerals and geothermal brines that can end up precipitating in the subsurface, in rock fractures, on casing, within the well bores, and also within surface equipment, such as pipes or turbines. And the reason the precipitation happen is usually a result of temperature or phase changes within the geofluid. And there's a lot of minerals that can precipitate. The ones that we called out as kind of the primary focus areas would be silicates, carbonates, and sulfates. We did include an et cetera on there because there are certainly other minerals that you all could propose to address within your application. So please know that, yeah, you can focus on things beyond what is listed there. Ultimately, what happens is this precipitation, tends to plug up the reservoir, plug up pipes, redirect flow, and change the heat transfer rates. So it just generally reduces process efficiency, and it's a problem that's pretty predominant across the geothermal industry, certainly at some geothermal fields more than others. But again, given the wide scope, we thought it would be a good topic area. So in terms of the current state of technology, there are several methods that we use to mitigate scaling issues. That can include acid injection, mechanical removal, usually kind of a scraping situation, or a pH modification of the geothermal brine. The thing is, all of these methods, while they are somewhat effective, they usually do require shutdown of certain wells or the surface equipment, and they're usually administered on an intermittent basis. So what we would like to see in terms of applications would be more advanced methods for inhibiting mineral scale. And yeah, that advancement could be related to the effectiveness of the method used, the efficiency, the cost, or also environmental considerations, if there's some benefits in that regard. So this could include a lot of things, again, open to many different solutions. Some of the ones that we came up with to focus on potentially would be other chemical treatments besides pH modification. Sometimes there's advanced coatings that one could apply to casing or to surface equipment. And I'm sure there's a myriad of other solutions that are potentially out there. So please keep your minds open as you think about all that. And just to emphasize one more time, we're thinking about both below the surface and above the surface. So we're talking reservoirs, wellbores, and surface equipment. So in terms of what we're not looking for necessarily would be applications that simply propose more traditional scale removal technologies, or things that are kind of clearly outside of this topic area. Critical metrics on this one, really it's mostly temperature related. We would like to focus on conditions, reservoir conditions, that is, where we have elevated temperatures above 390 F or about 200 C, and we'd like to focus on energy production situations. So not necessarily direct use or heat pumps, but energy production, electricity production. And again, just looking for something that's a little more effective than what we have now. As far as references, please take a look at the topic area within the FOA for a list of references that you can check out for more information. As far as partnering, I think that's pretty open in this case. I can see industry being involved, academia being involved, national labs, et cetera, et cetera. One thing I'll highlight is that we do have a geothermal data repository that houses a lot of public data on that's geothermal related. So the link is in the topic area description. If your project is, potentially looking at analyzing data, there's a lot of data within that geothermal data repository. And then I'll just finish up by saying phase 1 applications in this case should basically focus on proof of concept, and then phase 2, we would like to scale up. So that could be model validation in phase 2, prototype development, or field testing, whatever might be applicable to your project. So with that, I will wrap up, and let's see if we have any questions.
Yes, there are questions for subtopic A. How would you differentiate this problem from scaling on heating exchangers?
Oh, that's a good question. Let's see. I think there'd be a lot of similarities in looking simply at scaling on heat exchangers versus throughout the whole process. I do think that yeah, there'd be a lot of similarities happening. Some of the differences that would come in might be if we're taking a look at scaling down within the reservoir. You know, we might have, we certainly have different conditions down in the reservoir, higher temperatures, higher pressures, maybe you know, some geochemistry at play down there. Same thing in the wellbore. Again, probably that same, yeah, some similarities, but some differences, especially as you get deeper and deeper into the subsurface.
Okay, another question for, it could go for A or B. Are you looking for any large-scale geothermal areas inspection to discover the scaling via airborne sensors or UVAs?
I would not say that was necessarily something we would be focusing on the front end for this topic area. Now, that being said, if there is a way to, yeah, remotely sense, you know, some of the expected geochemistry or, yeah, which would ultimately, you know, lead to being able to predict, you know, some of the scaling issues that might occur. Yeah, I think, yeah, I don't see a direct path there necessarily, but if there is a path, yeah, to getting all the way to the tail end of the process there, please send me an email at william.vandermeer@ee.doe.gov.
Thank you. Are the GTO looking for a mineral scaling mitigation that is applicable to all different system types? Suppose that we are more familiar with one geothermal system type over the others, and want to propose a very novel and effective solution that is applicable to that system type only. Is that responsive to GTO's interest?
I would say yes, that is responsive. We understand that, yeah, there's differences between the geochemistry at all of our various geothermal locations within the United States. And yeah, if a solution is proposed that's maybe a little more local or regional, or potentially even only focused on one geothermal area, that's still fully within bounds, and we would take a look at that.
Thank you so much. We'll move to the next subtopic, and it's Mark. Dr. McCoy, are you online?
Yes, can you hear me?
Yes, go ahead, please.
Okay, so the topic here is related to geologic storage of CO2, and we're focusing on monitoring systems using electromagnetic methods. So what we're really aiming to do is to reduce the cost as well as improving the resolution of electromagnetic monitoring when applied in the deep subsurface. So what we're seeking in this case is the development of components that improve the resolution of electromagnetic techniques through the deployment of electrodes and/or sensors in deep boreholes at or near storage reservoirs. The electromagnetic systems may be deployable during the construction or abandonment of stratigraphic test wells, or built for purpose monitoring wells, or in repurposed pre-existing wells. Well-to-well designs and well-to-surface designs may be addressed. In the past, we have offered turnkey funding for development of turnkey systems and services, and that is not really the focus of this topic. It's really aimed at developing components that could be put into turnkey systems or services. So in terms of some of the things that we're wanting to put some focus on, is that the projects certainly should focus on the development of system components, that is hardware. But some of the proposed effort and the DOE funding can address overall system design, deployment options and methods, and data handling and processing software. But it really should not include interpretation of the data. So we're looking for novel or improved, reliable, rugged EM sensors, electrode systems, or other system components. So in terms of critical metrics, we're looking for hardening the permanent sensor arrays to last at least 5 years and perhaps up to 30 years. Design permanently installed arrays where data may be collected automatically and unattended. Design a field acquisition to provide good sensitivity in the injection zone, which could be at depths greater than 2,600 feet below the ground surface, and also be able to monitor changes at the boundary of the CO2 plume for CO2 injected. There can be use of capacitively coupled electric field measurements that may collect E-field data without direct contact to the formation. It's acceptable to use casing electrodes where the well casing in an observation or monitoring well in the injection zone is used as the electrode. Can design downhole data acquisition platforms where the collected data is digitally sampled and averaged prior to collection, and also systems that would make use of slim holes for monitoring wells. So in terms of important references or prior art, there are a few references that are provided at the bottom of the topic. There's no specific prior art that we wanted to cite for this particular topic. Expected partners might include those who design components, do field testing, manufacturing, as well as sales. And as for the expectations of phase 1 projects versus phase 2, phase 1 probably should focus on planning, design, prototype, development, and lab test, whereas phase 2 would probably focus on field test and demonstration of the components and then making further improvements based on the lessons learned. Any questions?
Yes, there are questions. Are responsive applications strictly limited to EM techniques, or are other non-EM approaches also allowable?
Yeah, for this particular topic, we're limiting it to EM approaches. We not long ago had a topic that did include electrical resistivity and a number of other approaches. And so this time we wanted to limit it specifically to EM.
Will the project on seismic technology be considered?
Seismic, no. And again, in the past, we have sponsored topics on both turnkey system design and services for passive seismic, as well as developing improved system components for passive seismic monitoring systems. But we have not put any topics out for active reflection seismic surveys or VSPs or those types of surveys, just because that seems to be a much more mature technology, and we're looking to develop other types of technology to work in situations where active seismic surveys don't work as well as they should.
Would enabling a contrast agent to improve resolution of EM be within the scope of this topic?
In this particular case, I'd say no. We didn't write the scope to cover the use of contrast agents. We have in the past funded some projects of that type for other geophysical monitoring methods. But in this particular case, the topic is more focused on developing components of the sensor system. But certainly what is being suggested here is something we could take into consideration for a future topic.
Okay. Are you looking for any large-scale geothermal area inspection to discover the scaling via airborne sensors or UVA?
Well, that probably goes outside the boundaries of my topic, but certainly the electromagnetic methods could have applicability in certain types of geothermal settings. And that potentially could include some airborne techniques, but the focus of our efforts under this particular topic would not extend to airborne techniques.
Thank you. Is the target just sensors? And is the data acquisition hardware assumed? And if so, what is the data acquisition hardware, or is the objective both the sensor and the data acquisition hardware?
Yeah, here the components can be electrodes or sensors or parts of the data acquisition system. So certainly data acquisition system components or entire data acquisition systems that would couple to this type of geophysical method of monitoring, that would fit within the scope of the topic.
Is the topic only looking for solutions involving electromagnetic technique, or might electrochemical methods, sensors also be considered?
Not in this topic. We're not considering electrochemical methods. It's only for electromagnetics.
What is the frequency of interest?
That probably exceeds my technical capability to specify that frequency. I'm not sure if we're able to provide further information. There are some references that are attached that would probably give some explanation with regard to frequencies here.
Can you elaborate on target resolution of the proposed system?
Well, certainly we want to improve the resolution relative to the deployment of surface arrays, which might give you a resolution at something like, equivalent to 1/4 of the depth in the subsurface where the plume of CO2 is located. And that can certainly be surpassed through improvements. And that's one reason why we're looking for downhole deployments here, is to improve the resolution.
Thank you. No more questions. We'll move to the next subtopic. And Dr. Dooley, are you online?
Yes, I am.
Go ahead.
All right, yes. For this topic, this is regarding CO2 transport systems and oxygen removal, looking into process modeling and assessment, and hoping to develop digital tools. As a backstory, integrated carbon management hubs are rapidly developing around the world. These systems are connecting various emitters to storage sites through transportation systems that typically can include pipelines, but also can span into ocean-going carriers, railways, intermodal containers, and river barging. From a source perspective, in the future, we're seeing integrated developments that have the potential to tie in new sources of CO2, sources from concrete, steel, refining, and among other emitters. So as we know, as these systems develop and they mature, we're seeing more stringent quality specifications on CO2 become apparent. There's some various examples in Europe, but also in the United States, where there's considerations on the impurities of the CO2 being allowed into the system and those concentrations being reduced over time. Some of these impurities can range from oxygen, sulfur oxides, nitrogen oxides, hydrogen, among others. So for this particular topic, we're looking at oxygen. We're hoping in particular, because this one can lead to oxidation of metal surfaces, pipeline corrosion, and the formation of solids in transportation systems and potentially the downstream surface and subsurface. In light of this, we're seeking digital tools and technologies that can model oxygen removal technologies and anything applicable to CCS. We're hoping to get the concentration down to 10 ppm moles or less, as we're seeing that's typical industry guidance. And we're seeking the digital tools to be able to model some of the process, understanding some of the cost estimation related to that process and the conditioning equipment, and then being able to predict some of the CO2 stream compositions, especially the waste product stream and then the product stream. The tool sought out could be either a digital plugin tool or a standalone tool. We have not specified any type of platform, so anything from Excel to Aspen HYSYS to Aspen Plus to Pro 2, all of those platforms could be applicable. Also, we're just making sure that it's useful for the industry. We're seeing, products or impurities being managed more stringent now. So we're just trying to make sure that we're developing tools that can help inform the industry and as CCS develops.
Thank you. No more questions, so we'll move to the next topic. Oh, I see a question. Thank you for excellent explanation. Is this a large energy system modeling project? Where in the energy system is the reduction in O2 concentration desired?
Typically, it is still open. Historically, oxygen has been treated at the emitter, but if this is a plug-in tool or a standalone process, theoretically, it could also be located at a central processing facility where various emitters and their CO2 streams could then be treated and polished. So we still leave that open right now, and it's to the applicant's precedent of what they prefer and what they propose.
Thank you. There's another question. Let me see. We do notice some other DOE solicitation also interested in tuning of AI optimization features for digital tool being developed. Is this something that the DOE are interested as well for this subtopic?
From my understanding, I think we're just trying to model what's state of the art in oxygen removal right now. I'm not aware of whether AI or machine learning could improve upon those tool sets that are existing. If so, we welcome the application, but it is not required to include AI or machine learning in the application itself for this topic.
Thank you. Is this a large energy system modeling project?
I do not actually know what that means, so I apologize. I would say that this is more of a plugin or tool to where I think it would complement various other software tools that can model the carbon capture system or the carbon transport system.
How about hydrogen?
Hydrogen as an impurity is not being focused on at this time. It could be considered in the future on future topics.
Thank you. No further questions, so we'll move to the next topic. 11.
So Zena, this is Adam Kinney, the portfolio manager for Basic Energy Sciences. Dr. Clarence Gallimore was unable to make the meeting today due to a conflict. So I will try and do a very brief readout on this particular topic and encourage everyone that's interested to directly reach out to Dr. Clarence Gallimore with their technically specific questions. So should I go ahead?
Yes, please go ahead.
Okay, cool. So as you can see, this is a particular topic is supported by DOE's Office of Nuclear Energy, specifically their Advanced Materials and Manufacturing Technologies program, for which Dr. Clarence Gallimore is the federal program manager. I'm not going to go into a lot of detail. You can find all the information on the two particular subtopics that are included here in the solicitation. This topic, though, in brief, is seeking applications for R&D for novel engineering materials that are supporting nuclear reactor systems. So there are specifically two subtopics, one which was included last year. The first one, powder metallurgy, hot isostatic pressing of high temperature metallic alloys, and then a new topic on advanced materials for structural applications I would note one thing, I think, on the first subtopic on powder metallurgy, hot isostatic pressing. This was included last year, but there has been some changes relative to the previous version of this topic. Notably, that applications are being sought to understand the cause of property degradation, in addition to what was included last year, which was development of improved processes for high temperature alloys, including but not limited to powder chemistry specifications, powder manufacturing, etc. So again, to avoid saying anything incorrect, since this is not my area of expertise, I refer you to both the solicitation and to reaching out to Dr. Karen Scallimore with specific questions. I'll stop there, Zena. Thanks.
Thank you so much. So there are two questions. Should I just reach out to Dr. Karen? Yes, please reach out directly to the topic manager. Do we need to target a particular reactor cycle like molten salt or metal? Do we need a partner with DOE lab or industrial nuclear partner? Can you answer?
I'd rather not answer simply because I just don't want to speak incorrectly for Dr. Karen Scallimore. So I would direct that question to him specifically.
Thank you so much. Please, for the people who have submitted questions for topic 11, please reach out directly to Dr. Derek Karen Gilmore with your questions. The email is on the screen and also is on the topic documents. And with that, we come to the end of our webinar for today. And as we indicated at the beginning of the webinar, that this webinar recording, along with a copy of the presentation, will be posted on our website under the Funding Opportunities page. Here we are, you have our contact information. Please feel free to contact us with any questions you may have. And that will be all for today's webinar. Remember, we have 2 more webinars on July 24 and 25. If interested, please go ahead and register for these 2 webinars. The registration links are on our website. And join us tomorrow and on July 25th. Thank you for attending and have a good evening.